All right, welcome back to the fourth installment. Today we're going to be looking at the distance formula. All right, let's go.
Hey, what's going on? It's Justin Dickmeyer from engineeringtrainingexam.com, and in this video we're going to discuss the distance formula. So what is the distance formula? Well, essentially the distance formula is a restatement of the Pythagorean theorem packaged up into a simple equation that will allow us to find the distance between two given points. So let's consider the 2 points, -2, 1, and 1, 5. Now it's the standard process to find the distance of these 2 points. We can simply graph them and then draw a straight line between them and then develop a triangle as such, with this being side A, this side being side B, and the hypotenuse, which is the distance between the 2 points, being side C. So graphically, once again, it's easy to find what C is just using the Pythagorean theorem, which is A squared plus B squared is equal to C squared. So using this process, we can simply find out that if this is a 0.15 and this is -21, that we can see that A is going to be 3 and B is going to be 4. So if we just plug that into the Pythagorean theorem here, we find that 3 squared plus 4 squared is equal to C squared. And just calculating that out, we find that it is equal to 9 plus 16, which is equal to 25, which is equal to C squared. And we find that the hypotenuse, or the distance between these 2 points, is the square root of 25, which is equal to 5. So this method obviously holds true in any case. However, the distance formula, like I said, repackages this formula into a simple equation that we can just quickly plug in any two given points in a coordinate system to figure out what the distance is between those 2 points. So the distance formula states that d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, and all that is under the square root. Now this is, of course, if we're given x1, y1 and x2, y2. So all we need to do is plug this given information into the distance formula, and we will be able to determine the distance between those 2 points. So let's look at a quick example here. Let's say that we're given the points -3, -2, and we're given the point 5, 2. Now we can go ahead and graph this, make a triangle, determine the sides A and B, and solve for the hypotenuse C. Or we can go ahead and just take our distance formula and plug in the information that we were given, which we will do in this case. So d is equal to the square root of x2, which in this case is 5, minus x1, which is -3, all that squared, plus y2, which is 2, minus y1, which is -2, all squared. So working that out, we get the square root of 8 squared plus 4 squared, which comes down to the square root of 80. And just throwing that into our calculator real quick, we find that the distance between these two given points is 8.94. So that's essentially it, guys. Not much to it. It just, once again, is the distance formula is once again a restatement of the Pythagorean theorem. It just allows us a quick, concise way to plug in two given points and define real quickly what the distance is between those 2 points. So if you guys have any questions, go ahead and visit my site.
All right, that was a good video covering the distance formula. Basically, you're using it to find the x and y coordinates on a grid. If you were given 2 points and trying to find the third to form a right triangle, and this is an alternative to the Pythagorean theorem, which is handy if you are given the length of the sides, but if you're just given the coordinate values, then the distance formula works better. It'd be distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared, and you're solving for your you're plugging in your two values and you're solving for the one that's missing. All right, that is it. Thank you.